Summary. Dear students, let us summarize what we have learned in this chapter. The main features of this chapter are as follows. Empty relation. Empty relation is the relation R in X given by R equals phi such that phi is a subset of X into X. Universal relation. The relation R in X given by R equals X into X is called a universal relation. Reflexive relation. A relation R in X is a reflexive relation with A, belonging to R for every A belonging to X. Symmetric relation. A relation R in X is a symmetric relation satisfying A, B belonging to R implies B, A belonging to R. Transitive relation. A relation R in X is a transitive relation satisfying A, B belonging to R and B, C belonging to R. Implies that A, C belongs to R. Equivalence relation. A relation R in X is an equivalence relation if it is reflexive, symmetric, and transitive. Equivalence class. Equivalence class containing A belonging to X for an equivalence relation R in X is the subset of X containing all elements B related to A. A function f defined from x to y is 1, or injective if fx1 equals fx2. This implies x1 equals x2 for every x1, x2 belonging to x. A function f defined from x to y is onto or surjective if given any y belonging to set y for every x belonging to set x such that fx is equal to y. A function f defined from x to y is 1, and onto or bijective if f is both 1 and onto. The composition of functions f defined from a to b and g defined from b to c is the function gof defined from a to c given by gof x is equal to g of fx for all x belonging to a. A function f defined from set x to set y is invertible if for every g defined from y to x such that gof is equal to ix and fog is equal to iy. A function f defined from x to y is invertible if and only if f is 1 and onto. Given a finite set x, a function f defined from x to x is 1, respectively onto if and only if f is onto respectively 1. This is the characteristic property of a finite set. This is not true for infinite set. A binary operation star on a set A is a function star from A into A to A. An element E belonging to X is the identity element for binary operation star defined from X into X to X if A star E equals E star A for all A belonging to X. An element A belonging to X is invertible for binary operation star defined from X into X to X if there exists B belonging to X such that A star B equals E equals B star A, where E is the identity for the binary operation star. The element B is called inverse of A and is denoted by A inverse. An operation star on X is commutative if A star B equals B star A for all A, B in set X. An operation star on X is associative if A star B star C equals A star B star C for all A, B, C in set X.